Discover the precision, power, and innovation behind nuclear reactor installation and other advanced industrial manufacturing processes shaping tomorrow's energy and engineering landscape. The manufacturing process of the VVER-1200 reactor pressure vessel begins with steel melting, where high-quality pearlitic steel grade is produced. From this alloy, an enormous ingot weighing up to 360 tons is cast, forming the basis for the vessel's exceptional strength. The ingot is then heated and subjected to forging, during which powerful presses gradually shape the steel into thick, uniform shells capable of withstanding extreme operating pressures and temperatures. Next, the lower section of the vessel is formed through stamping of the bottom head. A massive double-acting press delivering more than 15,000 tons of force precisely shapes the steel into its hemispherical contour. After forming, the workpieces undergo extensive mechanical machining, including boring, facing, and contouring to achieve accurate dimensions. Critical areas are strengthened through weld overlay, ensuring corrosion resistance and long-term durability. The vessel components then pass through controlled heat treatment, relieving internal stresses and improving mechanical properties. Quality assurance follows with X-ray and radiographic inspection, allowing technicians to detect internal defects and verify structural integrity. Finally, the completed vessel is subjected to rigorous hydrostatic testing, confirming its ability to safely operate under high pressure before entering nuclear service. The AtomMash facility, part of the Volgodonsk branch of AEM Technology JSC, stands as Russia's largest industrial plant dedicated to nuclear power engineering. Located in Volgodonsk, Rostov region, the plant was officially commissioned in 1978 and has since become a cornerstone of the nation's high-technology manufacturing sector. As shown in the video, AtomMash impresses with its vast workshops, advanced production lines, and highly specialized equipment. The plant is one of the main suppliers of heavy components for the nuclear industry, including reactor vessels and other critical systems. Additionally, it produces large-scale equipment for the oil and gas sector and thermal power generation. Today, AtomMash continues to demonstrate the capabilities and ambition of Russian industrial engineering. Dirostahl is a modern heavy forging specialist whose roots lie deep in the industrial history of the Bergisches land and the 400-year forging tradition of the Dederichs family. From these origins, the company has developed into one of Europe's largest and most advanced open-die forges, continuously expanding its production halls, workshops, and highly skilled workforce of nearly 500 employees. Today, Dirostahl maintains around 30,000 tons of input material in numerous block formats, focusing on engineering steels, alloyed and quenched and tempered grades, case-hardening steels, as well as stainless, acid-resistant, and heat-resistant steels. Its standard program includes more than 100 materials according to German and international standards, with the capability to produce special high-alloy grades in close cooperation with customers. Precision begins with sawing the input material to calculated weights on more than 20 circular and band saws capable of handling diameters up to 800 millimeters, lengths of 15 meters, and individual weights of 35 tons. Heated to 550 to 250 degrees Celsius, the preforms are forged on steam hammers and hydraulic presses. Smaller pieces up to 500 kilograms are manipulated by hand tools, requiring exceptional teamwork and craftsmanship, while larger workpieces are handled by electro-hydraulic manipulators. For extremely heavy forgings, 2 4-column underfloor presses with up to 40 meganewtons force shape axles and drive shafts in a single operation. Dirostahl also operates 2 state-of-the-art ring rolling mills, producing seamless rings up to 500 millimeters in diameter and 8 tons in weight, with tight tolerances and optimized material flow. Heat treatment, performed in 33 furnaces with modern burner technology, imparts the required hardness, strength, and toughness through quenching, tempering, normalizing, or solution annealing. A fully equipped 9,000 square meter machining shop delivers precise turning, milling, deep hole boring, and carousel machining for parts up to 35 tons. Comprehensive ISO 9001 certified testing, including ultrasonic inspection, tensile and impact tests, and spectrometric analysis, ensures full traceability and reliability. Supported by an automated high bay warehouse and a dedicated logistics fleet, Dirostahl supplies sophisticated forgings for applications ranging from wind turbines to heavy machinery worldwide. After the hot shaping processes, each steel component at Dirostahl undergoes product-specific heat treatments to achieve its ideal physical properties. The steel is enhanced through hardening at temperatures up to 950 degrees Celsius and tempering up to 750 degrees Celsius. 33 state-of-the-art tempering and hardening furnaces ensure cost-efficient and environmentally friendly treatments. These processes include not only hardening and tempering, but also a range of annealing methods such as isothermal, stress relief, normalizing, and solution annealing at 1,250 degrees Celsius. Proper heat treatment reveals the hidden qualities of cold steel, whether it is achieving specific service hardness, wear resistance, ease of machining, or high Charpy impact values. Continuous flow installations allow seamless rings to be treated efficiently, saving energy and reducing costs. SIA Rotons is a Latvian manufacturing company founded in 2006 and based in Amuri, Atazu Novads. Specializing in large-size plastic products, the company primarily serves water and sewage systems, offering solutions that combine durability, functionality, and innovative design. Rotons produces both serial products and custom items tailored to individual project specifications. Its main product lines include insulated water meter wells such as PM400 and PM500, septic tanks and biological purification systems, including RS Bio6 and SBR-type solutions, as well as complex sewage pumping stations with diameters up to DN3000. Additionally, the company manufactures grease separators, flow meter and gate wells, tanks for both surface and underground installation, and rainwater storage solutions. Rotons also provides plastic pallets, road barriers, and various garden products. With a commitment to quality, SIA Rotons accommodates special orders and custom 3D design development, establishing itself as a trusted partner in Latvia and beyond for advanced plastic engineering solutions. In this process, automated equipment precisely swivels the roof of the electric arc furnace, EAF. This swiveling action allows easy access to the furnace interior, facilitating charging, tapping, and maintenance operations. By automating the roof movement, the system enhances safety for operators and optimizes workflow, reducing downtime. The smooth, controlled rotation ensures efficient production, maintaining consistent furnace operation while minimizing risks. This advanced mechanism is a key component in modern steelmaking efficiency and safety. The construction of tunnel rings is a critical stage in modern underground excavation, and it is primarily carried out using tunnel boring machines, commonly known as TBMs. These machines are long cylindrical structures, specifically designed to excavate tunnels with circular cross-sections through a wide variety of geological conditions. TBMs represent the state-of-the-art in tunnel construction technology, offering a safe, efficient, and precise alternative to traditional methods such as drilling and blasting. A TBM operates with a rotating cutting head located at its front, which can bore through different materials including rock, soil, sand, or clay. As the machine advances, the excavated material is transported away from the cutting face via a conveyor system, allowing continuous and uninterrupted progress. The precision and power of the TBM enable it to maintain the intended tunnel alignment while minimizing disturbances to the surrounding ground, a crucial factor when tunneling under urban areas or sensitive infrastructures. One of the remarkable features of modern TBMs is their ability to install tunnel lining segments immediately after excavation. These segments, usually made of precast concrete, are assembled by a robotic system positioned at the rear of the machine. As the TBM advances, these segments form a continuous, reinforced tunnel lining that provides immediate structural support and ensures long-term stability. This automated ring installation significantly accelerates the construction process while reducing the need for additional manual labor inside the tunnel. The TBM method not only increases construction speed, but also enhances safety compared to traditional excavation techniques. By maintaining a stable tunnel face and supporting the excavated section immediately, TBMs minimize the risk of collapses and ground settlements. Additionally, the mechanized approach reduces noise, vibration, and disruption, which is particularly beneficial in densely populated areas. Overall, TBMs and their ring-building capabilities have revolutionized tunnel construction. They combine excavation, material removal, and structural lining installation into a single continuous process, ensuring efficiency, precision, and safety. The ability to build tunnel rings automatically behind the advancing machine represents a significant technological advancement, enabling large-scale underground infrastructure projects to be completed more quickly and reliably than ever before. The assembly of the 7.1 APM VCT vertical circulating water pump is a precise process that ensures reliable operation and optimal performance. The procedure begins with the assembly of the outer column and the installation of the suction bell. The outer column provides structural support and guides the flow of water into the pump, while the suction bell ensures smooth fluid entry with minimal turbulence. Next, the pumping element and diffuser bearing are assembled. The pumping element, including the impeller, is carefully mounted to ensure correct alignment and efficient fluid movement. The diffuser bearing is installed to provide stable support for the rotating components, reducing vibration and wear during operation. Following this, the shaft coupling is fitted to connect the pumping element to the drive system, ensuring smooth torque transmission. The assembly continues with the installation of the inner column, which is inserted within the outer column to guide the vertical flow path. The foundation plate is then positioned and secured, providing a solid base for the pump and ensuring alignment with the discharge piping. Once the structural components are in place, the discharge head is installed. This part directs the pump fluid to the desired outlet and houses several critical components, including the stuffing box. The stuffing box is carefully mounted to prevent leakage around the pump shaft while allowing smooth rotation. Subsequently, the bearing housing is installed, providing support and lubrication for the rotating shaft. The motor support is positioned, followed by the installation of the electric motor, which drives the pump. Proper alignment of the motor is critical to avoid excessive wear and ensure long service life. After all components are installed, the pump is connected to the test loop, where it undergoes a series of performance and functional tests. These tests verify flow rate, pressure, vibration, and overall operational efficiency. Any necessary adjustments are made to ensure that the pump meets design specifications. Through the systematic assembly process, the 7.1 APM VCT vertical circulating water pump is constructed to deliver reliable, efficient performance in industrial and water circulation applications. Every step, from structural assembly to testing, is critical for ensuring the pump operates safely and effectively over its service life. The careful transfer of nuclear fuel handling equipment from a barge to the AtomMash facility, a critical step in supplying nuclear power plants. Large, cylindrical components, painted green and securely strapped, are being lifted by a heavy-duty gantry crane designed for precise and safe handling of extremely heavy loads. The operation takes place on a specially constructed dock, allowing the barge to position the equipment close to the shore for efficient unloading. Skilled operators coordinate every movement, ensuring that the equipment is aligned accurately and lowered gently to avoid damage. This stage is crucial for maintaining the integrity of the components, which will later be installed in the reactor systems of the nuclear power plant. The process highlights stringent safety protocols, meticulous planning, and advanced lifting technology. By transporting these components from the barge to the facility, engineers ensure that the nuclear plant receives the essential equipment needed for safe and reliable operation, supporting energy production and industrial development. The TBM Christina S646 is a state-of-the-art tunnel boring machine designed for large-scale urban subway projects. Along with its sister machine, TBM Elisabetta, Christina S646 boasts impressive specifications, featuring a diameter of 6.3 meters, an overall length of 97 meters, and a total weight of 650 tons. These dimensions allow the machine to efficiently excavate circular tunnels, simultaneously supporting the tunnel structure during construction. Its robust engineering ensures precision, safety, and productivity, making it an essential tool for complex metro projects. Primarily, Christina S-646 was deployed by the construction company Gulermak Heavy Industries for the expansion of the Warsaw Metro Line 2. This ambitious project included both the central section and the extensions to the Wola and Bemowo districts. The TBM operated in multiple stages, tackling varying geological conditions and urban constraints. Its advanced cutting head, powerful drive system, and integrated muck removal mechanism allowed it to bore efficiently while minimizing disruption above ground. Throughout its operational life, Christina S-646 achieved notable progress milestones. For instance, by October 2020, it had driven 630 meters from the Paustenkau-Slaskich station, completing critical sections of the line. Earlier that year, in August, it successfully finished the shortest tunnel segment of the project. These achievements highlight the TBM's reliability and its critical role in maintaining project schedules. After completing all designated tunneling scopes for the entire Line 2, the TBM Christina S-646 was systematically disassembled. Its decommissioning marked the end of a highly productive phase in Warsaw's metro expansion. Throughout its operation, the machine exemplified modern tunneling technology, combining immense scale, advanced mechanics, and careful project planning. In conclusion, TBM Christina S-646 not only demonstrated engineering excellence, but also contributed significantly to the development of Warsaw's urban infrastructure. Its deployment allowed for rapid, safe, and precise tunnel construction, establishing it as a benchmark for future metro projects in the city and beyond. At the Akkuyu nuclear power plant construction site in Turkey, the installation of the Unit 1 reactor pressure vessel is a critical milestone. Specialized cranes carefully lift the massive, precision-engineered vessel into its designated position within the reactor building. Skilled engineers and technicians monitor alignment and secure the vessel with exacting accuracy to ensure safety and operational reliability. This meticulous process involves coordination of heavy lifting equipment, strict adherence to technical standards, and thorough inspections. Completing this stage marks a key step in assembling the nuclear reactor, advancing the power plant toward future energy production. The installation of a hydropower unit is a highly coordinated and technically demanding phase that brings together mechanical, electrical, and control systems to form a complete generating block. The process begins with the installation of the turbine and generator, which represent the core components of the entire unit. The turbine is precisely positioned on its foundation to ensure perfect alignment with the water flow, while the generator is mounted above or adjacent to it depending on the design. Accurate balancing and alignment are essential to guarantee smooth operation and long-term reliability. Following this step, the pressurized water conveyance system is installed. High-pressure penstock pipes are connected from the reservoir or intake to the turbine, forming the main passage through which water is directed into the runner. All joints, anchors, and supporting structures are carefully assembled to withstand hydraulic pressure and prevent leakage. This system plays a decisive role in delivering the energy of flowing water to the turbine blades efficiently. Finally, the automatic control system and auxiliary equipment are installed and integrated with the main components. This includes sensors, monitoring devices, excitation equipment, and protection systems. Once connected and calibrated, the control system enables remote operation, real-time adjustment, and safe management of the hydropower unit. Together, these stages ensure the generating unit is ready for testing and commissioning. The manufacturing process of a nuclear power plant involves a series of highly controlled and precision-engineered steps. First, massive forgings and steel components are produced to form the reactor vessel and primary systems. Next, these parts undergo machining, heat treatment, and rigorous inspections to ensure flawless quality. Advanced welding and assembly techniques are then applied to integrate the reactor core, piping, and safety systems. Finally, each module is tested, certified, and prepared for transport to the construction site, ensuring safe and reliable plant operation. AtomMash, a branch of AEM Technologies in Volgodonsk, is Russia's only enterprise capable of producing a complete set of nuclear reactor equipment. The plant manufactures both reactor vessels and steam generators using advanced, high-tech machinery. Its greatest strength, however, lies in its highly qualified specialists, many of whom are trained at the local MIFI Institute. Through close cooperation, students gain theoretical knowledge, practical experience, and mentorship, ensuring a strong workforce for the plant's cutting-edge nuclear production. Andritz Hydro represents a successful partnership that merges advanced Andritz Group technology with strong Brazilian industrial tradition. Located in Araraquara, the company delivers reliable, efficient, and sustainable hydropower solutions. With extensive global experience, it provides innovative turnkey systems for small, medium, and large hydro plants. Supported by modern facilities and robust logistics, ZIEMEX is a leading Alsace-based company with 230 employees and an annual turnover of about 25 million euros, exporting 70% of its heavy industrial equipment. The company specializes in high-value products made from stainless steel and nickel alloys for the pharmaceutical, chemical, and food industries. ZIEMEX values motivated individuals, embraces advanced technologies such as laser fabrication, and invests in young talent to preserve its expertise and long-term capabilities. The production of power generators at WKV follows a meticulous and highly specialized process. First, all structural components and steel parts are manufactured in the company's dedicated steel construction area. High-quality segmented laminations are then assembled to form stators, while in-house coil fabrication ensures exceptional flexibility and consistent winding quality. Skilled technicians carry out the manual construction of stator cores, and rotor windings are produced using first-class winding machines developed by WKV itself. All components undergo rotational drying in one of Europe's most advanced impregnation plants, followed by precise dynamic balancing to minimize vibration. Even the final assembly of large machines requires outstanding accuracy. Comprehensive testing and careful packaging guarantee that every generator reaches its destination in perfect condition. The Basque oil and gas industry presents a comprehensive portfolio of advanced capabilities that support global energy projects. Its companies supply high-quality mooring and lifting solutions, precision-engineered tubes, pipes, pipe fittings, and flanges. They also provide reliable fastening systems, industrial valves, and a wide range of pumps and compressors tailored for demanding operations. In addition, the sector manufactures durable pressure vessels, boilers, and professional hand tools, demonstrating a strong commitment to innovation, safety, and long-term performance